Hi, my name is Evan Woodbury, and this is the final project for the Managing Machine Learning Projects course, which is course 2 of 3 of the AI Project Management Specialization with Duke University. And the project is to choose a problem that might be a good thing to solve with a machine learning solution and walk through the high-level steps to implement the solution or to manage this project. So the 5 steps are those that you see here on the screen, and I will walk through each one. So to start with the opportunity evaluation, and basically, why is this a problem and why is it a good opportunity for machine learning to solve? So the problem that I've selected is predicting when customers will call into a service hotline. And this is the problem because if customers are calling into a service hotline, it means they may not be getting the type of service or the outcome that they are expecting. I believe with machine learning, we can predict when they're calling so we can proactively solve the issue and make it a better customer experience. For this example, the reason that a customer might be calling could be they are, for example, not receiving the package that they are expecting in time, or they called for a service technician and that technician has not arrived and they are expecting. So they follow up, they call the service hotline and basically ask questions because we or the company are not meeting the expectation. And again, this is the problem because it means we're not meeting our customer expectation. And it also means it's probably going to be costly to take that call. Costly because of the staffing needs to have people answering those calls all the time, and costly because that means those employees cannot be working on other tasks during that time. This would be a good project to solve using machine learning because there is likely a vast amount of data related to these types of events, and predicting why a customer might call with all those different factors could be really challenging without using machine learning. I'll walk through the CRISP DM business understanding process. CRISP DM stands for the cross industry standard process for data mining, and it's a process basically to organize and implement a machine learning project. So first, I'll talk about the problem and then what success looks like. So when defining the problem, one of the things you want to start with is the target user. For this, it would probably be the operations partners that are taking these phone calls. And it could also be their managers and the technology team that would help implement this type of solution. Another target user here could be the customer because we're likely going to try to push them updates before they call in to talk to the service hotline. The problem statement is that we need to be able to predict when customers are likely to call in. And as I talked about before, this matters because if we can predict when they're going to call in, we can take proactive steps before they reach out to us and hopefully avoid their bad experience while also saving us costs. Today, in many cases, this is likely solved with a heuristic model or kind of an if-then, where if certain things don't happen, then we might know we should proactively reach out to the customer with an update. And in many cases, it's probably done by a kind of use your own judgment approach where people are instructed, if you think the customer might be getting upset here, then we might want to get them an update. There's obviously a lot of gaps within that current state and customers who are not having their expectations met. For defining success, one of the things that we want to do is quantify the business impact. And here we want to look at basically what would the increased revenue or retention or some other business metric be if we were able to improve this? And what would the internal cost be as well? So for example, can we reduce the internal cost to take these calls by 20% while raising customer satisfaction scores for these events by 20% as well? The constraints for this project could be the amount of time before the predicted event happens that we are getting that prediction. So for example, if the prediction comes only 2 minutes before the customer might call, that might not be enough time to actually improve the situation and get them a better outcome. If it's 30 minutes or an hour or even a day before, then I think we probably have enough time to get a better outcome. There are output metrics and then outcome metrics as well. So an outcome metric, an output metric from this model could be something like the percent likelihood a customer will call in the next 8 hours. The outcome metric would be a 20% reduction in customer calls. Now, validating the solution. So there are a number of steps it takes to validate that your solution is working. And you kind of want to do those in an iterative process to make sure that you are still on the right path and still want to proceed. You want to start with validating the solution by making a mock-up and sharing that mock-up with a potential user to confirm if it's something that would even be helpful and if they could actually use it in practice. Then you'll want to take a look and see if the data is even available to make that prediction or to get to that end state or that mock-up that you showed the users. Then you'll want to create a very simple model, usually some type of if-then model using the data you have. So that's a very basic model to understand, like, is the kind of the high-level structure of what you're thinking actually realistic? And if you find that an if-then model doesn't work at all, then you might have some missing data or some data quality concerns. If you're getting okay results with this if-then model, then it might be a good situation to use a machine learning model to get an even better result. At that point, you'll want to create a very basic machine learning model and see what type of results you are getting. There are a few key machine learning system design decisions that you have to make, and these can impact the effectiveness of the model and also the cost, and there's kind of trade-offs for each. So first, you want to decide, is your model going to be in the cloud or on the edge? On the edge basically means that it is in a handheld device or basically in the specific device that you are using, rather than sending information back and forth between the cloud. Usually an edge approach is used if there's data privacy concerns or you need an instant response. The situation will probably use the cloud since we're not trying to get a result to a smartphone or anything like that, and there's no privacy concerns. We'll also always have an internet connection, so the cloud is a better solution, whereas if you're on the edge, you don't always need an internet connection. There's also offline versus online learning. And basically, how often is the model training, and is that being done frequently all the time, or is that being done offline? For this model, it can likely be done offline because we don't need it to learn and adjust really, really quickly. One example of where you would need something to learn and adjust quickly is autonomous driving, because it needs to constantly take in information and then change the prediction based on that. For this model, it's okay if we have a little bit of a lag because we're likely dealing in hours or days instead of seconds or milliseconds. And then we also need to determine if we want batch predictions or online predictions. Online predictions basically mean you might get a prediction every single seconds or minutes, or just it's kind of real time, whereas batch means you might get new predictions every 5 minutes, every maybe 1 minute, 5 minutes, 10 minutes, things like that. For this, I think a batch approach would be efficient because, again, we're likely dealing in much larger timeframes, and that is a more cost-effective approach than doing online predictions. Just like offline is more cost-effective than online for learning as well, and in general, the cloud is more cost-effective than edge. So for this model, speed is not the primary concern, so we can go with the approaches that are usually a little bit easier, a little bit more cost-effective. Then finally, the potential risks in production. There are a few that we want to consider here. One, the model may not be giving relevant or be giving good enough predictions if we don't have enough data. So if there are things that are impacting the model, such as for example, the weather that's not in our data set, then that could us bad predictions. For something like predicting when a package could arrive, the weather could be a really, really important factor. Latency could also be an issue. If, for example, we are having a hard time predicting when the customer might call and we can only get a prediction within, for example, 3 minutes before they're going to call, that could be an issue because we might not be able to solve the problem in enough time. So we need the model to be able to give us predictions far enough out so we can fix the problem before it arises. Concept drift could also be a concern, where if we built a model around why customers are calling today based on the factors that are relevant today, that could change over time. Customers could have different preferences or expectations over time. Customers may, for example, want to start shopping different ways, and that those different ways might not be included in our model. So you could have basically a drift in what's happening in the real world versus the data the model was trained on. That is all I have for the final project. Thank you for watching.